Hello, so I'm happy to be here again for another video about my cloud learning path. And here we go immediately. We resume our course, which is Reliable Google Cloud Infrastructure Design and Process. So now in this module, we'll see Google Cloud and hybrid network architectures. Let's have a look at what's this about.
In this module, we discuss Google Cloud Network architectures, including hybrid architectures. We will start by talking about how to design VPC networks to optimize for cost, security, and performance. Then we'll cover the configuration of global and regional load balancers to provide access to services. As part of the load balancer configuration, you can enable Cloud CDN to provide lower latency and decrease network egress, which ultimately decreases your networking costs. We will also introduce the Network Intelligence Center to evaluate your network's architecture and go over the network connection options, including peering, VPN, and Cloud Interconnect.
Okay, so there's a bunch of networking stuff to test
started by designing Google Cloud networks
and play around.
Google runs a worldwide network that connects regions all over the world. You can use this high bandwidth infrastructure to design your cloud networks to meet your requirements such as location, number of users, scalability, fault tolerance, and latency. Let's take a closer look at Google Cloud's network. This map represents Google Cloud's reach. On a high level, Google Cloud consists of regions, which are the icons in blue, points of presence or POPs, which are the dots in gray, a global private network, which is represented by the blue lines, and services. A region is a specific geographical location where you can run your resources. This map shows several regions that are currently operating, as well as future regions and their zones. The POPs are where Google's network is connected to the rest of the internet. Google Cloud can bring its traffic closer to its peers because it operates an extensive global network of interconnection points. This reduces costs and provides users with a better experience. The network connects regions and POPs and is composed of a global network of fiber optic cables with several submarine cable investments. In Google Cloud, VPC networks are global, and you can either create auto mode networks and have one subnet per region, or create your own custom mode network where you get to specify which region to create a subnet in. Resources across regions can communicate using their internal IP addresses without any added interconnect. For example, the diagram on the right shows two subnets in different regions with a server on each subnet. They can communicate with each other using their internal IP addresses because they are connected to the same VPC network. Selecting which regions to create subnets in depends on your requirements. For example, if you are a global company, you will most likely create subnetworks in regions across the world. If users are within a particular region, it may be suitable to select just one subnet in a region closest to these users and maybe a backup region close by. Also, you can have multiple networks per project. These networks are just a collection of regional subnetworks or subnets. To create custom subnets, you specify the region and the internal IP address range as illustrated in the screenshots on the right. The IP ranges of the subnets don't need to be derived from a single CIDR block, but they cannot overlap with other subnets of the same VPC network. This applies to primary and secondary ranges. Secondary ranges allow you to define alias IP addresses. Also, you can expand the primary IP address space of any subnets without any workload shutdown or downtime. Once you define your subnets, machines in the same VPC network can communicate with each other through their internal IP address regardless of the subnet they are connected to. Now, a single VM can have multiple network interfaces connecting to different VPC networks. This graphic illustrates an example of a compute engine instance connected to 4 different networks covering production, test, infra, and an outbound network. A VM must have at least one network interface, but can have up to 8 depending on the instance type and the number of vCPUs. A general rule is that with more vCPUs, more network interfaces are possible. All of the network interfaces must be created when the instance is created, and each interface must be attached to a different network. Shared VPC allows an organization to connect resources from multiple projects of a single organization to a common VPC network. This allows the resources to communicate with each other securely and efficiently using internal IPs from that network. This graphic shows a scenario where a shared VPC is used by 3 other projects, namely service projects A, B, and C. Each of these projects has a VM instance that is attached to the shared VPC. Shared VPC is a centralized approach to multi-project networking because security and network policy occurs in a single designated VPC network. This allows for network administrators' rights to be removed from developers so that they can focus on what they do best. Meanwhile, organization network administrators maintain control of resources such as subnets, firewall rules, and routes, while delegating the control of creating resources such as instances to service project administrators or developers.
Okay, so this is not new to us. We already had this in other courses of the same learning
path. Load balancers offered by Google Cloud, each designed for specific use cases. Application load balancers operate at the application layer, layer 7 of the OSI model. They are ideal for applications that require load balancing based on HTTP or HTTPS headers, cookies, or URL paths. Application load balancers provide features like SSL, TLS, termination, session affinity, and content-based routing. Network load balancers operate at the network layer, layer 4 of the OSI model. They're suitable for load balancing based on IP addresses and ports. Network load balancers are often used for TCP and UDP traffic, as well as for scenarios where low latency and high throughput are critical. They support features like TCP UDP load balancing and health checks. For more information on load balancers, please refer to the Cloud Load Balancing Overview documentation. With public IPs, traffic will be traversing the internet, so it is a best practice to use SSL for both application load balancers and proxy network load balancers. When configuring an application load balancer, HTTP is the default protocol in the Google Cloud console for the front-end configuration, and HTTPS requires explicit selection together with the certificate. For a proxy network load balancer, SSL is the default in the front-end configuration. Now, If you're using application load balancing, you should leverage Cloud CDN to achieve lower latency and decrease egress costs. You can enable Cloud CDN by simply checking a box when configuring a global external application load balancer. Cloud CDN caches content across the world using Google Cloud's edge caching locations. This means that the content is cached closest to the users making the requests. The data that is cached can be from a variety of sources, including compute engine instances, GKE pods, or cloud storage buckets. To determine which cloud load balancing product to use, you must first determine what traffic type your load balancers must handle. As a general rule, you'll choose an application load balancer when you need a flexible feature set for your applications with HTTPS traffic. You'd choose a proxy network load balancer to implement TLS offload, TCP proxy, or support for external load balancing to backends in multiple regions. You choose a pass-through network load balancer to preserve client source IP addresses, avoid the overhead of proxies, and to support additional protocols like UDP, ESP, and ICMP to UDP. You can further narrow down your choices depending on your application's requirements, whether your application is external, internet-facing, or internal, and whether you need backends deployed globally or regionally. If you prefer a table over a flowchart, we recommend this summary table. The load balancing scheme is an attribute on the forwarding rule and the backend service of the load balancer, and indicates whether the load balancer can be used for internal or external traffic. The term managed in the load balancing scheme indicates that the load balancer is implemented as a managed service, either on Google frontends, GFEs, or on the open source Envoy proxy. In a load balancing scheme that is managed, requests are routed to either GFE or to the Envoy proxy. For more information on network service tiers, refer to the documentation. As part of our discussion in designing VPC networks, I also want to mention the Network Intelligence Center. The Network Intelligence Center is a Google Cloud service that can be used to visualize your VPC's network topology and test network connectivity. The left-hand graphic shows a simple network topology visualization with external clients in 3 different regions, and traffic routed through an external load balancer to resources in US Central 1. This facility is extremely valuable for confirming the network topology when configuring a network or performing diagnostics. The right-hand graphic shows a configuration of a connectivity test between a source and destination along with a protocol and port. The following tests can be performed: between the source and destination endpoints in your VPC network, from your VPC network to and from the internet, from your VPC network to and from your on-premises network.
Okay. These topics are better explained and explored in the core services courses. So let's see here the exercise.
Network characteristics for your case study and select the type of load balancer required for each service. In the first part of this activity, describe the network characteristics of each of your services by filling out this table. The example shown here is for the account service. Because this is a backend service, it will only be accessed internally using TCP, and we don't plan to deploy the service in multiple regions. Then, based on the network characteristics for each of your services, select the right load balancer using this table. Based on the parameters from the last slide, we will use a regional TCP load balancer. Refer to activities 8A and B in your design workbook to fill out similar tables for your services, and feel free to explore Cloud CDN to decrease latency and network egress costs.
Okay, let's open the workbook. Whoa. Okay. So the workbook is here. We have to do this exercise here. 8A and 8B. So exercise 8A, service. Let's go with the same 4 services here, for which we defined our need for storage. Now we'll define our need for networking. Internet facing or internet only. So this will be internet itinerary definition will be used, will be called by our trip designers. Therefore, I will say internet, as they will not be in the same infrastructure. Itinerary view and mode, internet, and the analytics will be internal only. But internal in this case doesn't mean internal, it's not internal in the sense that it will be a computer inside the network which can work with the local IP only. I mean, in that case, we'll have the reporting. So the analytics will be internal only, and the reporting will be an internet. Will need an internet availability. This will need an application load balancer. Yes. No, multi-regional. At first I will start publishing the website in only one region, even if customers from other regions may suffer a bit of latency. I hope this is not an issue. So for now I will not put any multi-regional option. The itinerary will be also application load balancer, itinerary view mode, also analytics. The analytics service will not have an application load balancer. Well, in reality, yes, because the reporting service, which will be used by a user to query the analytics service, then will need an application load balancer, and the analytics service will receive calls which will log events, analytics events, which need to be kept in consideration. Therefore, all of them will use application load balancer, if I'm not wrong. We'll see. I'm not sure about this. We'll have to check this when we'll actually realize this system. Select the load balancers for your services. I mean, it's kind of redundant, the exercise, but yeah, we'll do it anyway. Okay, so we've done everything. Now we can get back here, mark as completed. Okay.
In this activity, you were asked to specify the network characteristics of each of your services and choose the appropriate load balances for each one. Here's an example for our online travel portal, ClickTravel. The inventory and order service are internal and regional using GCP.
Let's focus our attention on Google Cloud's network connectivity products, which are peering, Cloud VPN, and Cloud Interconnect. If you're trying to connect two VPC networks, you might want to consider VPC peering. VPC peering allows private RSC 1918 connectivity across two VPC networks, regardless of whether they belong to the same project or the same organization. Now remember, each VPC network will have firewall rules that define traffic that is allowed or denied between the networks. This diagram shows a VPC peering connection between two networks belonging in different projects and different organizations. You might notice that the subnet ranges do not overlap. This is a requirement for a connection to be established. Speaking of the connection, network administrators for each VPC network must configure a VPC peering request for a connection to be established. Cloud VPN securely connects your on-premises network to your Google Cloud VPC network through an IPsec VPN tunnel. Traffic traveling between the two networks is encrypted by one VPN gateway and then decrypted by another VPN gateway. This protects your data as it travels over the public internet. And that's why Cloud VPN is useful for low-volume data connections. As a managed service, Cloud VPN provides an SLA of 99.9% monthly uptime for the classic VPN configuration, and 99.99% monthly uptime for the high availability VPN configuration. The classic VPN gateways have a single interface and a single external IP address, whereas the high availability VPN gateways have two interfaces with two external IP addresses, one for each gateway. The choice of VPN gateways comes down to your SLA requirements and routing options. Cloud VPN supports site-to-site VPN, static routes and dynamic routes using Cloud Router, and IKE v1 and IKE v2 ciphers. However, static routes are only supported by Classic VPN. This diagram shows a Classic VPN VPN offering.
Classic VPN topology versus the H something VPN. HA VPN, yeah, I have seen this. This case, HA VPN has more tunnels.
VPN configure route priorities, support site gateway address. Let's walk through an interface and
there's a lot of details to know about these services. I mean, just having these videos like this, it's not productive for me this moment. I had a really good course about this with labs, which made it clear about the differences and how to configure these two type of VPNs.
Cloud VPN supports both static and dynamic routes.
And also the routers and the firewalls.
Cloud Interconnect has two options for extending on-premises networks: dedicated interconnect and partner interconnect.
And also the interconnect. Yeah, the interconnect obviously doesn't have any lab. It was only theory.
Per second. In both cases, over the interconnect between the cloud router and your on-premise.
So yeah, let's
This will allow for the user traffic from the
continue.
on-premises network to reach Google Cloud resources on the VPC network, and vice versa. Partner Interconnect provides connectivity.
In this design activity, you draw a diagram that depicts the network requirements of your case study. Let me show you a simple example. This network diagram shows where the network boundaries are and how traffic is served from our users through a load balancer to our backend. You could also include the use of Cloud CDN, Cloud VPN, or any Cloud Interconnect services that are relevant to our network design. Refer to Activity 9 in your workbook to create a similar network diagram for your services.
Okay, we'll do it now. First, let's put this in pause. Okay, so using a similar diagram, we need to just draw this diagram, your network. Of course, I will use this. And okay, this will be, here we'll have users, customers, or trip directors or guides. Okay. They will be able to use both mobile and web. They will have this authorization service. Yeah, which, okay. Then we'll have a global application load balancer. Yeah, then the user interface will send requests to different services, which in one case will be interview form service. Okay, and in the other case will be the itinerary definition service. Okay, and then we'll have the itinerary database, and there we have this itinerary view modification service. Then we have also the analytics, but in this case the analytics will not need anything about the VPC. There will be just some detached services. Okay, and they will be isolated in the sense that they will share the space, the VPC. Okay. And the data warehouse. Okay. Okay, now we have an idea about what's this going to be.
In this activity, you were asked to create a diagram that depicts the network requirements of your application. Here's an example for our online travel portal, ClickTravel. User traffic from mobile and web will first be authenticated using a third-party service. Then a global HTTP load balancer directs traffic to a public-facing search and web UI services. From there, regional TCP load balancers direct traffic to the internal inventory and order services.
Interesting, this detail about the VPN between the analytics and reporting service. Okay.
Reporting service that accesses the analytics service over a VPN. This might be good enough to start, and we could refine this once we start implementing it.
Okay, we're close to the end of this module. There's the module quiz. So first of all, first question, you are deploying a large-scale web application with users all over the world and a lot of static content. Which load balancer configuration will likely be the most suitable? With users all over the world, a large web application, so application load balancer with SSL configured and CDN enabled. CDN allows you to cache stuff, and as we have a lot of static content, we will benefit from a caching system where CDN, let's remember, GCP CDN stands for Content Delivery Network. Okay. You are a large bank deploying an online banking service to Google Cloud. The service needs high volume access to mainframe data on premises. Which connectivity option will likely be most suitable? On premises, for me, high volume access, which excludes a VPN, and I will say cloud interconnect. You have a contract with a service provider to manage your Google VPC networks. Okay. You want to connect a network they own to your VPC. Okay. Both networks are in Google Cloud. Which connection option should you choose? VPC peering, as they are different organizations. You want a secure private connection between your network and a Google Cloud network. There is not a lot of volume. VPN could be good, but the connection needs to be extremely reliable. Which configuration below would you choose? VPN with high availability and cloud router. 100%. Okay, man, I'm your networking guy here. So let's go. Let's see the module overview.
In this module, you learned about Google Cloud Networking and how to design networks that meet your application security, performance, reliability, and scalability requirements. We also covered the different options to connect networks using peering, VPN, and Cloud Interconnect.
Nice. Therefore,
In this module, we discuss the different.
now there's the next module, which will be done in another video. Therefore, I will just close here the video. I'm really grateful that I've been here, and I hope this was useful for you.